Hi, my name is Azamin Sabri. In this project, I'm assigned to do introduction. Background of the study. Calories. It means that it might provide your body with that many calories in the form of energy. Look at the food's protein, carbohydrate, and fat content first before calculating its calories by engaging in physical activity such as walking, by climbing stairs. Your body burns calories, but by carrying out the most fundamental physiological process, it also burns them. For instance, the process of breathing, maintaining body temperature, and pumping blood throughout the body all require energy continuously. The activity that burns the most calories per hour is running. Swimming, walking, and stationary bicycling are other fantastic possibilities. So for objective of this study, first of all is to explore relationship between amount of calories burns and distance of running. Number 2 is to calculate variable amount of calories burned by 60 runners. And lastly is to predict the amount of calories burned if the runners run in certain distance. So for significance of this study is that we can learn a lot of important things from our studies. We can classify the type of variables of each of the mentioned variables in the shown data based on the study we conducted. In addition, we are skilled at reading SPSS data and expressing the information. Make a regression from the provided data by providing an expression based on the data. For the limitation of this study, the study's restriction is that no question and answer session can be held to further demonstrate the data's correctness because it is already available on the StatCrunch website.
Well, thank you, Azamin. I'm Mohammad Shukri Mohammad Suib, and I'll be presenting the next slide, which is Chapter 2, Methodology. So, 2.1, Data Description. So, for this study, data description used is primary data. The data collected directly from the respondents by distributing questionnaires to the respondent, which is the runners. 2.1.1, the population. So the population of this study involved all varieties of runner. And 2.1.2, the sample. So 60 samples were selected from all varieties of runner with different amounts of calories burned and different distance of running. So 2.1.3, the sampling technique. So the data collected from cluster sampling by using convenience sampling methods. So the researchers will distribute the notice with link of the questionnaire through social medias such as Facebook, WhatsApp, Instagram, and Twitter. The respondents or the runner will go through the notice will answer the questionnaire on the spot. This method was very easy to carry out. Moving on, for 2.1.4, data collection method. The data was collected using an online survey questionnaire method. The respondent had given an online list of questions to be answered in the Google form. There were 4 steps in order to collect the data by using this method. Firstly, the researcher will greet the runners and explain briefly the intention of these studies. Secondly, the runner will choose their gender. And thirdly, the respondents will state their calories burned and their distance of running that the runners go through while conducting the activities. Lastly, the respondent has to click on the submit tabs in order for the researcher to receive the data. So moving on to 2.1.5, the description of the variables. This study was carried out to find the relationship between the understanding of distance of running to the amount of calories burned by the 60 runners in total. First variable of this study was the distance of running. Both of the variables were quantitative, discrete. The data can be expressed as a number and numerical response which arise from a counting process. So back to 2.1.2, which is the sample, and as we can see, they are all data that are formed from the statistics. So they are mean, median, mode, standard deviation, variance, skewness, range, minimum, maximum, or percentiles. So that's all for me. Thank you.
Assalamualaikum and good evening. My name is Mohammad Asyraf bin Hamilamzah and I will be presenting about 2.3 numerical technique and 2.4 method used to achieve objective. Numerical technique is used in this case study to analyze and differentiate each of the characteristics of the quantitative variable that are available in the set of data. The table below represents all the methods used in numerical technique. For measurement, measure of central tendency is for statistic mean, median, and mode. Measure of dispersion is for variance and standard deviation. Measure of position for first, second, and third quartile. Shape of data distribution is for percent coefficient of skewness. However, these methods in numerical technique that is shown in table 2.3 above is not appropriate to describe a qualitative variable, but qualitative variable can still be described by using another method. And then for 2.4, methods used to achieve objective. Okay, from the table 2.4 methods to achieve objective. Objective to describe the quantitative and qualitative variables using numerical technique by using box plot, histogram, measure of tendency, measure of dispersion, measure of location, and measure of data distribution. To determine the shape of data distribution for qualitative variables is by using percent coefficient of skewness. Then, to compare the dispersion of percentage of calorie burns based on the distance of running by using coefficient of variation. And then lastly, to determine the correlation between the distance of running and calories burned by using percent coefficient of correlation. In order to achieve the objective that we set for this study, the following methods was used in this study shown in the table 2.4 below.
Hi, now I'll be presenting the result and data interpretation. So first of all, I'll be talking about the data presentation. As you can see, we use a simple table but full of valuable variables and values keyed in. The table shows all we need to know about the distance and calories burned by the runners. Next, we move on to histogram. The graph shows the positive data sets, which presents the calories burned by the 60 runners which we've surveyed. Based on the histogram above, the calories burned is 600 and the lowest is 100 and below. The distribution of the histogram shows skewed to the right, whose value is 0.326. The mean value is 282.67 and the median is 241.50. This graph, on the other hand, shows the negative data set, which presents the distance by the 60 runners. Based on the histogram above, the longest distance is 6.00 and above, and the shortest is 1.00. The distribution of the histogram shows a skew to the left, whose value is negative 0.201. The mean value is 3.7347 and the median is 2.7015. Now we continue to box plot. This box plot shows the calories burned by the 60 runners. The median is 241.50. The interquartile range is about 484 calories burned, which indicate that 50% of calories burned among the runners is 241.50. Meanwhile, this shows the box plot of the distance by the 60 runners. The median is 3.7015. The interquartile range is about 5.17 distance, which it indicates that 50% of the distance by the runners is 3.7015, as we can see here. Now to summarize it all, we can see from the case summaries here, the mean value for calories burned for both male and female runners differs, which are 273.30 and 292.03 respectively. Meanwhile, the standard deviation for calories burned for both genders are also different. For male, the standard deviation is 108.615 and female is 135.658. For distance, mean distance for male and female are 3.6575 and 3.8120 respectively. The standard deviation of the distance for male is 0.1549 and for female is 1.24798, which can be seen in the table. That's all from me. Without further ado, I pass the presentation to my other team members. Thank you.
I will present about conclusion that we get from this project. From this study, it can be concluded that the relationship between variables, amount of calories burns, and distance of running shows a positive correlation. Next, the graph that is suitable for this data is the histogram. Besides, the value of the mean for this data is 282.67. The standard deviation is 122.202 and the interquartile range is 241.50. For this data, the value of correlation is 0.831, which suggests a strong correlation relationship between variable amount of calories burned and the distance of running by 60 runner. The value of beta 1 is 89.904, means that for every increase in distance of running, the total calories burned will increase by 89.904. That's all for me. Thanks for watching.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afifah binti Suhimi from AS1204A.
Assalamualaikum warahmatullahi wabarakatuh. My name is Yusrabiatul.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Halim Eqmal bin Kadir. Student ID 2020830526.
Assalamualaikum, my name is Mohammad bin Johar. My student ID is 2020868344. Now we to talk about the background of study. We, the semester 4 student, has carried out the research to meet the requirement of STA108. The purpose of this research is to find out the relationship between the weight of a person and the cholesterol level. The study is to see that the cholesterol level is affected by the weight of a person, if it is always changing. This data is collected by asking 55 different people at random about their cholesterol level and their weight that varies. How do one person know that the amount of cholesterol is too high in our own body? To understand the significance of cholesterol towards our body, we need to know what is the impact toward our health and if the cholesterol level is too high or too low. Hence, the study is conducted. Other than the dependent variable and the independent variable, which is the cholesterol level and the weight of a person, we must also know that there are other variables such as age and gender.
I will start with the objective. One of the objectives is describe the quantitative and qualitative variable and determine the shape of data for it. Besides, compare the dispersion of cholesterol level and weight of a person based on qualitative variable using coefficient of variation. We also need to determine correlation between cholesterol level and weight of a person and predict the amount of cholesterol level and weight of a person.
For the Chapter 1 Introduction 1.3 Significance of Study that was conducted has produced a variety of advantages, one of which is the development of statistical reasoning skill. Throughout the study, students have also gained writing skill for statistic report, as we are incorporating the theory that we have learned in the course syllabus into our own project. We were also given a greater understanding. The inclusion of science in the project has improved our ability to draw conclusions from the correlations between project variables. Other than that, study project like this one, including the method employed, may aid us in future studies in the field of science. In order for students to do research effectively and methodically, research needs to be documented and statistically presented. This will aid students in conducting research in an ethical and methodical manner.
Data description. To do statistical analysis, secondary data is used in this work, which is the qualitative variable and quantitative variable. The variable that are used in this study are cholesterol level and weight of person. The variable cholesterol level is a quantitative continuous type of data and a ratio level of measurement. The weight of a person is also a quantitative continuous and a ratio level of measurement.
Chapter 2 Methodology 2.2 Graphical Technique. There are various graph types that can be used to analyze data. The graphs are bar chart, box and whisker plot, histogram, and scatter plot. But for this group project, my group only used 3 graphs, which is bar chart, box and whisker plot, and a histogram. In order to evaluate the data distribution for each variable in the first step of this research, a graphical technique was necessary. In table 2.2 below, the graph for each variable is displayed. For the type of variable, qualitative, the variable is count and the graph is bar chart. And for the quantitative variable, the variable is weight, which is used a box and whisker plot and histogram. And second one of variable quantitative variable cholesterol, we use box and whisker plot and histogram.
Other than graphical technique, numerical technique also been used to examine the characteristic of each quantitative variable. The mean, median, mode, percentile, range, variance, and standard deviation are the most commonly used numerical measure for quantitative data. The mean, often called the average, is computed by adding all the data values for a variable and dividing the sum by the number of data value. In this study, the measurement we use is to measure of centrality is mean, median, and mode. Measure of dispersion is variance and standard deviation. Measure of position is first, second, and third quartile. And last but not least, shape of data distribution by using Pearson coefficient of skewness. Fortunately, for qualitative variable, it is not suitable to describe the data using numerical method as shown in table. However, we still can describe the qualitative variable using frequency distribution table.
For the data presentation, the section presents the data described in Table 2.2 and Table 3.3. Figure 3.1 Table 1 shows the bar chart and the frequency distribution of the people that were chosen at random. We can see that the percentages of men a bit higher than the female. And Figure 3.2 until Figure 3.5 above present the histogram and box plot for variables such as gender, cholesterol level, weight and weight of person. We can see that the shape of the data distribution for cholesterol level and weight of a person are skewed to the right. We can analyze it even further by examining it using Pearson coefficient of skewness in order to confirm the shape of the data distribution.
Next is descriptive statistic analysis. As we know, previous section has its own quantitative and qualitative variable, such as the qualitative only limited analysis can be performed, which can be represented by graph and frequency distribution table. This shows that quantitative have more analysis that can be observed using measure of central tendency, measure of dispersion, and measure of location. As this can prove that we can know the minimum weight of a person is 45.84 kg, while the maximum weight of a person is 106.14 kg. The lowest cholesterol level is 164 mg over dl, and the highest cholesterol level is 288 mg over dl. A measure of central tendency is a single number that reflects the middle of a dataset, and we can know such as the average weight is 68.0407 kg, while the average for cholesterol is 215.98 mg over dl. The median for variable weight is 67.1900 kg, and for the cholesterol is 210 mg over dl. Majority of the person have weight and cholesterol level are 64.86 kg and 206 mg over dl respectively.
Last but not least, correlation and regression analysis. Correlation analysis is used to assess the nature and strength of the link between two variables, which are typically referred as independent and dependent variable. There are three ways to find correlation, which are Pearson's product moment, the quantitative variables coefficient of correlation, a graphical technique, scatter diagrams, and Spearman's rank coefficient of correlation for quantitative and qualitative variables. Regression analysis is to estimate the best fit line to show the relationship between dependent and independent variable. It can be utilized to assess the relationship strength between two variables. The regression equation is y equal to a plus bx, where a is the y-intercept, b is the slope of the line, and x is the independent variable. The Pearson correlation from the SPSS output is 0.217. This means that there is low correlation between cholesterol level and weight of person. For the y-intercept is 192.780, and for the slope from the SPSS output is 0.341, meaning that when the value of weight of person is increased, the cholesterol level is increased. The complete regression equation is y is equal to 192.780 times 0.341 x. The prediction of PSA when the weight of a person is 58 kg, y is equal to 192.780 plus 0.341 multiplied by 58 equal to 212.558 mg over dl. The coefficient of determination from the SPSS output is 0.047, that are equal to 4.7%.
As a conclusion, the primary goal of this study was to establish the relationship between cholesterol level and weight of a person. To examine the data, numerical and graphical methods are employed. Examples of graphical approach include box and whisker plots, histograms, and bar chart. The outcome of our work was that we discovered how to produce a statistical report. We must divide the standard deviation by the mean and multiply the result by 100 to determine the coefficient of variation. More consistency is implied by less relative variation than by bigger relative variation. We could do more than merely collect data. We could make various graphs based on the information we have gathered.
That's all from us. Thank you for listening.
Assalamualaikum and greetings to Madam Judiza and viewers. In this video, our group will present a study on variable age and cholesterol level, the descriptive correlation and regression analysis. This will be presented by our group members, which is me, myself, Nur Afifah, Nur Shazwani, Nur Afifah, and Nurmieya. We will start with the introduction, background of study. Cholesterol is a type of fat of animal-based product that is consumed by the body. There are three types of cholesterol, which is low-density lipoprotein, LDL, high-density lipoprotein, HDL, and very low-density lipoprotein, VLDL. Having cholesterol in the body is necessary, but excessive cholesterol may cause problem. The data that are used in this study was taken from internet, which is the link shown. The variable in the data is age, gender, and cholesterol level. The number of samples of the data is 55%. Age in unit year is the independent variable, while cholesterol level in the unit mg/dl is the dependent variable in this data. In general, cholesterol level is a measure of the total amount of cholesterol in human blood. The normal cholesterol level is different for everyone depending on some factor. How did age affect the cholesterol level in an individual? For example, only women will undergo menopause. So before menopause, women tend to have lower total cholesterol level compared to men. However, after menopause, women's total cholesterol levels tend to rise and become higher than men's. This is how gender affects the cholesterol level in an individual. Age or the lifetime of an individual also bring effect to cholesterol level. The older the person goes, the cholesterol level will also rise. Therefore, this study was conducted by a group of semester 4 students, which is us, to fulfill the syllabus requirement in STA108 Basic Statistics and Probability. We choose this topic, age relationship with cholesterol level. Next is the objective of the study. The study was conducted to achieve the objective, which are to describe the age, cholesterol level, and gender using graphical and numerical technique, to determine the shape of data distribution for age and cholesterol level, to compare the dispersion of cholesterol level and age based on gender, to determine the correlation between age of a person and the cholesterol level of a person, to predict cholesterol level based on the age, and to determine the accuracy of prediction of cholesterol level based on the age. Next is the significance of study. A lot of benefit result from the study, such as student statistical skill using the statistical package for social science (SPSS) are improved and developed. Students will also improve the skill of writing statistic report and communication skill among the group members. And the study involved science-related topics and the required methodology employed, which are important in science study. This will help students in science field study in the future. Throughout the study, students can understand the relationship between age and cholesterol level in an individual. The discussion among the group members while doing the study showed the diversity of how different member viewpoint of the data given. So as the result, the data is presented in form graphically and numerically. That shows that the study has a good impact and is significant.
Next, moving on to the methodology. Firstly, data description. Data description or descriptive statistics are used to summarize or compile and describe variables about the cholesterol level and age of 55 persons. It can also be used to summarize one variable at a time to analyze the relationship between the cholesterol level and the age of 55 persons. Secondary data is used in this project to analyze the statistics, as the data in this study was retrieved from website statcrunch.com. Two quantitative variables and one qualitative variable were included in the set of data. This is the table of the general data description, and table 2.1 below summarizes the data of our project, which is the variable gender with the unit male and female, and the type of data is qualitative data, and the level of measurement is nominal. While cholesterol level is under the unit milligram, type of data quantitative continuous, and the level of measurement is ratio. While the last one is the variable age under the unit years, the type of data is quantitative continuous as well, and the level of measurement is ratio. Moving on to the graphical technique. Different types of graphs are used to interpret and analyze the data. There are histogram, bar charts, box and whisker plot, and scatter plot. Graphical presentation of the data is a crucial component in understanding, analyzing, interpreting, and as well as identifying the patterns and trends of the data. Secondly, graphical presentation of data helps in enabling the quick analysis of a large amount of data in a time and can aid in making predictions as well as informed decisions. The graph used for the variables are arranged in table 2.2 below. Bar chart was used to interpret the data in a graphical presentation. Qualitative data occurs when the information concerns an attribute or a trait and it is not numerical. Bar chart emphasizes the relative sizes of each of the categories being measured by using vertical bars in the study. Meanwhile, histogram as well as box and whisker plot were used to display the quantitative data visually. Both data were cholesterol level and the age of the 55 persons. The reason why histogram was used for the cholesterol level data is a histogram provides a visual representation of the distribution of the cholesterol level of the 55 people, its spread, and skewness of the data. Furthermore, histogram also helps to visualize and analyze the symmetry and the skewness of the data. In addition, histogram can visualize any outliers and gap in the data. Box and whisker plot were used to show the age of the 55 people data. A box and whisker plot were used to show the distribution of the data within a population. Box and whisker plot allows users to determine where most of the data are at a glance. In this study, box and whisker plot were used to visualize both age and cholesterol level. Next, moving on to the numerical technique. Numerical techniques are used in mathematics, statistics, and computer technological on how to create, analyze, and implement algorithms that acquire the numerical answers to problems using non-stop variables. Table 2.3 shows the measurement used for the statistics in numerical measures. The numerical measures shown in table 2.3 above are not appropriate for interpreting and analyzing qualitative variables. Hence, a frequency distribution table of the percentage of the qualitative data, which is the age, was used to analyze the qualitative variable. Table 2.2 in the graphical technique, which I presented to you just now, represents the qualitative variable and the quantitative variables that show the dependent and independent variable used. The dependent variable is the cholesterol level of a person, while the independent variable is the age of a person. By using the Pearson coefficient of correlation, scatter plot, and the regression analysis, more analysis can be done to find the connection between the cholesterol level and the age of the 55 people. Hence, it helps in predicting the cholesterol level with the given age. In addition, a best-fitting regression coefficient can be determined using the regression analysis. Table 2.3 above shows multiple numerical measures that are used in the study. This includes the measure of central tendency, measures of dispersion, measures of position and shape of the data distribution. Measure of central tendency that consists of mean, median, and mode are a summary measure that describes the whole set of data with a single value that represents the middle or the center of the data distribution. Meanwhile, the objective of measures of dispersion is to find out on the spreading of the data values are on the number line. Measure of dispersion consists of variance and standard deviation. Besides, measure of position aid in giving us a way to see where is a certain data value falls in a sample or in a data distribution. Measures of position can tell us whether a value is an average value or high value or a low value. While measures of position are usually used for quantitative data that falls on numerical scale, this includes the first, second, and third quartile. Lastly, shapes of distribution helps us in assisting with identifying other numerical measures, such as which measure of central tendency is appropriate to use in analyzing the data. For example, if the data is normally distributed, hence the measures of central tendency which consist of mean, median, and mode are all equal. Thus, all the measures of central tendency are appropriate. This is determined by the Pearson coefficient of skewness. The methods used to fulfill the objective of the study is tabled in Table 2.4, which are methods used to achieve objectives, from the qualitative data to quantitative data, from the graphical technique to the numerical technique.
First of all, as mentioned before, there is two variables which is qualitative and quantitative. In qualitative variable, a bar chart is used to represent the data. From the bar chart, we can see a slight difference between males and females. Based on the table, we can see that the percentage of male is higher at 50.9% compared to female at 49.1%. The percentage difference between males and females is 1.8%, which is not too noticeable. The frequency difference between both gender is only 1. Figure above represent the histogram for quantitative variable of a person's age and cholesterol level respectively. From the graph above, we can see that the shape of data distribution for a person's age and cholesterol level is skewed to the right. From the box plot graph for cholesterol level, we can see outliers on box plot. To confirm the shape of the data, further analysis can be explained by using the Pearson coefficient of skewness, which will be explained in section 3.2. As we know, skewness is a measurement of data distribution's lacks of symmetry. From the table, we can see that the value of skewness for age and cholesterol level are both positive. In this case, both variable age and cholesterol level are positively skewed to the right. This indicates that people of younger age have higher cholesterol level than people of older age. The table shows all the statistic data that we got from the SPSS output. As we can see, the minimum age is 18 years old, whereas the maximum is 72 years old. The cholesterol minimum value is 164 mg per dl and the maximum value is 288 mg per dl. This shows that as age increase, the cholesterol level increase. The mean or the person average age is 38.62 years old and the average cholesterol level is 215.98 mg per dl. The median for age and cholesterol level variable is 36 years old and 210 mg per dl respectively. The mode is the common value in a distribution, which is, in this case, is most of a person's cholesterol level is 206 mg per dl. The data also show that most people are 25 years old. From the table, the standard deviation for age is 14.624 years old and for cholesterol is 22.43 mg per dl. The variance for age and cholesterol level are 213.87 and 503.87 33.092 respectively. The age range is 54 years old, and for cholesterol level, the range is 124 mg per dl. For the first quartile, 75% of the respondent age are older than 25 years old, and 25% of the respondent age are younger than 25 years old. Meanwhile, 75% of cholesterol level is higher than 201 mg dl, and 25% of cholesterol level is lower than 201 mg dl. For the second quartile, half of the respondent was in age older than 36 years old, and the other half was in age younger than 36 years old. For cholesterol level, 50% of cholesterol level are higher than 210 mg dl, and the other half are lower than 210 mg dl. For the third quartile, 25% of the respondent was in age older than 48 years old, and 75% of the person was in age younger than 48 years old. For cholesterol, 25% of cholesterol level are higher than 232 mg per dl, and 75% lower than 232 mg per dl. Based on table for the age variable, the coefficient of variation of male is 36.5%, while 39.11% for females. For cholesterol level variable, the coefficient of variation for male is 8.68%, while 12.08% for female. The value for the coefficient of variation of both gender age is larger than the value for both gender cholesterol level. This indicates that the distribution of both gender age is less consistent compared to the distribution of both gender cholesterol level. Attached figure is a scatter plot of cholesterol level and age. From the scatter diagram, we can see that the point is a weak positive correlation between cholesterol level and age. This is a model summary table from the SPSS output. The Pearson correlation from the SPSS output above is 0.458, indicating a weak positive correlation between cholesterol level and age. The coefficient determination from the SPSS output is 0.21, which is equal to 21% of total variation in cholesterol level, which can be explained by age using the regression equation. This is a coefficient table from the SPSS output. The y-intercept is 188.848, meaning that when the person is 0 years old, the cholesterol level is 188.848 mg per dl. The slope from SPSS is 0.703, meaning that when the value of age increased by 1 years old, the cholesterol level increased by 0.703 mg per dl. From the previous value, we can form the complete regression equation, which is y equal to 188.848 plus 0.703x. The prediction of cholesterol level if the age of a person is 37 years old can be calculated as shown in the slide. From the calculation, the cholesterol level is 214.859 mg per dl if the person age is 37 years old.
Objective of this study includes describing the quantitative and qualitative variables using numerical and graphical methods, determining the shape of data distribution for quantitative variables, comparing the dispersion of quantitative variables based on qualitative variables, and to determine and predicting the relationship between dependent and independent variables. However, the focus of this study was to determine the relationship between age, X, and the cholesterol level, Y. The person cholesterol level is the data for the quantitative kind of variable, whereas age and gender are the data for the qualitative kind. The type of sampling approach employed in this inquiry was systematic sampling. This process is not randomized since the only sample unit is picked randomly, while the subsequent sample units follow a specific interval. Sample random sampling is similar, except the sample frame is not necessarily complete. The completion of this study yields a variety of advantages, including the acquisition of statistical skills using SPSS, and our investigation taught us how to use and create a statistical report. Thus, investigation must be documented and quantitatively presented for a better understanding. So, in Chapter 2, secondary data was obtained to analyze this experiment, which means that the data is earned by another person, which is someone other than the primary user. Numerical and graphical techniques are used to examine the data. Numerical methods are used in this study to find the characteristic of each quantitative variable. However, it is not suitable to examine the qualitative data. Hence, the graphical technique is used to study the data distribution for each variable in this data set. Example of numerical technique are a measure of central tendency, measure of dispersion, the measure of position, and the shape of data distribution. Examples of graphical methods are plotting bar charts, histogram, and box and whisker plots. In Chapter 3, various ways of methods were used to gain and interpret the data value. For example, in the coefficient of variation, we need to divide the standard deviation with the mean and multiply by 100. If the coefficient variation of the distribution sample A is greater than B, we can conclude that the distribution of B is more consistent than distribution of A. A larger relative variation implies less consistency, while a smaller relative variation implies more consistency. We also use the SPSS output to interpret our data. The present correlation from the SPSS output above is 0.458. This means that there is a weak positive correlation between the cholesterol level and the age of the patient. The coefficient of the determination of SPSS output is 0.210, equal to 21%, and the 21% of person cholesterol level can be explained by the age of the person using the regression equation. To conclude, all the methods used make the project more manageable and save up a lot of our time. We also learned throughout Chapter 1 until Chapter 3 is that we could do more than just collecting data. From the collecting data, we can make various charts depending on our collecting data. Charts are done to display more appealing data and explore more about the data itself. Every chart differ and give specific information based on what we want to find. In addition, based on the graph, we can know the pattern and the relationship between the variables x and y. In this study, we also use statistical methods of the data such as the mean, variance, and quartiles to interpret the data easily. Lastly, the correlation helps us to measure the strength of the relationship between the two variables in a data set. In contrast, regression analysis is used to describe the relationship between the independent and dependent variables.
That is all from our group. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, Ms. Jaliza. Today, our group 4, will be presenting on the title, A Study on Variables Age and Systolic Blood Pressure, the Descriptive Correlation and Regression Analysis. The group members of our group is me, myself, Imanina Liu. My student ID is 2020852444. Next is Nabihah Adibah, and then Nur Shereena and Nurmieya Shereena. Now we will be moving on to the introduction of our study.
I will present about Chapter 1 Introduction. Point 1 is Background of Study. Students in Semester 4 conducted research to fulfill the requirements for STA108, Basic Statistics and Probability. The study was carried out to examine if there was a link between age and systolic blood pressure. This is research on the variable age, Y, and systolic blood pressure estimate X. The study is being undertaken to examine if age is influenced if the estimation of systolic blood pressure varies. Data for this study was acquired from 125 people who were going to have their systolic blood pressure measured. Systolic pressure is measured as the heart beats, and diastolic pressure is measured when the heart relaxes. The pressure imposed by the blood on the arteries when the heart beats is measured as systolic blood pressure. The system ideal blood pressure is 120 mmHg. Aside from that, an increase in blood pressure with age is largely associated with structural changes in the arteries, particularly substantial stiffness of the arteries. Rising blood pressure has been linked to an increased risk of cardiovascular disease. Increased pulse pressure owing to increased systolic pressure is the most significant risk predictor in the elderly. The goal was to find out whether the standard target of 140 mmHg was superior to treating blood pressure to lower the systolic number to 120 mmHg or less. Many factors such as hormone, stress, exercise, eating, sitting, and standing can affect blood pressure. Blood flow through the body is regulated by the size of blood vessels, the action of smooth muscle, one-way valve, and the fluid pressure of the blood itself. There is only one type of variable, which is quantitative. Quantitative data in this research are continuous. The quantitative variable in this project include patient age and systolic blood pressure estimate. This project focuses on the relationship between age and the systolic blood pressure. For 1.2 objective of study. Firstly is to describe the quantitative and qualitative variables using graphical and numerical techniques. Second, to determine the shape of data distribution for qualitative variables. Thirdly, to compare the dispersion of age X and systolic blood pressure Y based on the qualitative variable. Next, to determine the correlation between age X and systolic blood pressure Y. And lastly, to predict the amount of age X and systolic blood pressure Y. Next is 1.3 significance of study. This study's findings are beneficial to all those who are worried about their health. This study will increase public knowledge about how aging affects blood pressure and how to maintain a healthy diet. As we become older, our blood pressure rises. This senior group is especially susceptible to therapies, adverse effects, including blood pressure drops. Moreover, we can study on how to control isolated systolic hypertension lowers overall mortality, cardiovascular mortality, stroke, and heart failure events. Next, we can know about highest number known as systolic pressure. We can indicate on how hard your heart is working to pump blood into your arteries. Especially the pressure in your heart when it relaxes between beats is shown by the bottom number of diastolic pressure. This is because both values were independent predictors of heart attacks and strokes. Next is Chapter 2 Methodology.
Assalamualaikum. My name is Nurmieya Shereena with Muhammad Riza, and I am presenting the methodology of this group project. Firstly, for the data description, the goal of data description is to keep track of all details of the data sets and the information so that the content and organization of the data in use in this study can be clearly understood. We may sensibly simplify massive amounts of information. With the help of descriptive statistics, as for this group project, the data used is secondary data given by the lecturers. In this data, there are 4 variables which are gender, systolic blood pressure, body temperature, and age of person. The units, type of data, and the level measurement for variables are also stated in the table. Next, moving on to the graphical technique. There is no way better to acquire a feel for the data than to present it in a figure or graph, since a picture really is worth 1,000 words or statistics. The main rule should be to include as much information as you can in the figure, while keeping in mind that the reader shouldn't become overwhelmed by the amount of information. So why bar chart for the variable gender? Qualitative data may be represented visually using bar graph. When information is not numerical and pertains to quality or attribute, it is referred to as qualitative or categorical data. For histogram, it is helpful when working with enormous data sets, like greater than 100 observations. It can assist in finding any anomalous findings or outliers or data gaps. So due to their similarities, bar graphs and histograms can occasionally be mistaken for one another. Although histograms similarly employ bars to graph data, they do so quantitative data that is numerical rather than qualitative, and that is measured at a different level. Lastly, for graphical techniques is box and whisker plot. A box and whisker plot can provide more information while enabling the display of different sets of data on the same graph. Box and whisker plots may combine data from several sources and present the findings in a single graph, making them incredibly efficient and simple to read. Lastly is numerical technique. So numerical technique, the creation and examination of methods that offer rudimentary but accurate answer to pressing problems is the ultimate objective of numerical analysis. The tactics used are described in the table. As seen in the table, those numerical measures were used and a single number that seeks to characterize a set of data by pinpointing the central location within the set of data is referred to as a measure of central tendency. You are probably most familiar with the mean, but there are additional central tendency measures, including the median and the mode. Despite having completely separate data sets, two data sets might have the same mean. The degree of variability must thus be known in order to characterize data. The dispersion measurement provides this information. For this measure of dispersion, range, standard deviation, and variance are employed. Ordered data collection is separated into 4 equal halves for position measurement using quartiles. The first, second, and third quartiles designated respectively by the letters Q1, Q2, and Q3 are the values that divide each sector. Last but not least, the shape of the distribution is determined by the Pearson coefficient of skewness. Moving on to chapter 3.
Assalamualaikum. My name is Nurmieya Shereena and I will present you the result. 3.1. Based on the table, it shows a bar chart and frequency distribution of respondents' gender. Based on the table and figure, we can see quite big difference in percentage between female and male respondents. The percentage of female respondents is higher than male respondents, and the difference is 26%. The percentage of female respondents is 63%, while the male responding is 37%. The table also states that frequency of female and male respondents. The frequency for female respondent is 85, while the male respondent is 50. The difference in frequencies between these two genders is 35. Next is represent the histogram and box plot of systolic blood pressure of respondent, while figure 3.1.4 and figure 3.1.5 represent the histogram and box plot of body temperature of the respondent. The histogram graph, the data distribution for this variable is skewed to the right. A box plot was also included to support the variables. Based on the box plot, the shape of the data distribution is positively skewed. Next is 3.2. This table shows the minimum of systolic blood pressure is 80 millimeters mercury and the maximum of systolic blood pressure is 236 millimeter mercury. For body temperature, the minimum level is 50 Celsius and the maximum level is 100 Celsius. Table 3.2.2 summarizes the statistic for a measure of central tendency of this research. Based on the table, an average level of systolic blood pressure is 133.59, while body temperature is 48.90. The median of systolic blood pressure is 130, while body temperature is 47. Not just that, the table also summarized that most of the respondents have a systolic blood pressure level of 120, while a body temperature level of 40. Next table shows the summary statistic of measure of dispersion. Based on the data, the standard deviation of systolic blood pressure is 27.850, while body temperature is 50.273. The variance of systolic blood pressure is 755.648, while body temperature is 263.272. The range for systolic blood pressure is 156, while the body temperature is 85. Next table is a summary statistic for measures of central position. It shows that about 25% of the respondents have less than 150 systolic blood pressure, and half of the respondents have systolic blood pressure less than 130, while 75% of the respondents have systolic blood pressure less than 150. About 25% of the respondent levels were less than 39 body temperature. Half of the respondents' level were less than 47 for body temperature, while 75% of the respondents' level were less than 60 for the body temperature. Next, for the 3.3, it will explained by Imanina.
For 3.3, correlation and regression analysis, there are four subtopics that I will be further and explain, which are firstly coefficient of variance, second correlation and regression, third Pearson correlation, and last but not least model summary. For the first one, coefficient of variance. The coefficient of variance is a statistical indicator of how evenly distributed the data points in a data collection are with respect to the mean. When comparing the level of variation across different sets of data, it serves as a representation of standard deviation to mean ratio. Based on the table that you can see from our presentation, coefficient of variation of systolic blood pressure for male is 20.6%, whereas the female is 21.1%. And the coefficient of variation of body temperature of the male is 27.9%, whereas the female is 31.2%. The value of the coefficient of variation of systolic blood pressure for female is greater than male. Other than that, the value of the coefficient of variation of body temperature for female is also greater than male. This concludes that the distribution of systolic blood pressure and body temperature in female is more consistent than the distribution of systolic blood pressure and body temperature in male. Moving on to correlation and regression analysis, I would explain briefly. It is a statistical method known as correlation analysis, which is used to assess the significance level of the link between two variables, which are typically referred to as, first one is independent variable, second is dependent variable, xy. So the correlation analysis is to study how variables are associated. To sum up the entire concept of the study, the ability to use correlation to determine the possible relationships between variables allows you to infer or forecast potential future activity or future studies. There is a figure of scatter plot of blood pressure and body temperature. I'm sorry I couldn't show in the table or the slide because I couldn't copy paste. The figure shows that the scatter plot of systolic blood pressure and temperature, there is a weak positive correlation between systolic blood pressure and body temperature. This is because both of the variables tends to go up in response to one another, but the relationship is not very strong, moderate. So the Pearson correlations, moving on. The Pearson correlation from the SPSS output is 0.352. This means there's a weak positive correlation between systolic blood pressure and body temperature. That means the changes in one variable are not correlated with changes in the second variable. The value in the table is less than 0.5, which is 0.0. Thus, there is statistically significant correlation between systolic blood pressure and body temperature. That means increases or decreases in systolic blood pressure do significantly relate to increases or decreases in body temperature. Coefficient of determination from the SPSS output is 0.142, which is equal to 12.4%. And 12.4% of total systolic blood pressure can be explained by body temperature using the Pearson correlation. That the conclusion of our report summary is that mostly, the objective of this study is to identify and predict the relationship between dependent and independent variables, describing the quantitative and qualitative variables, which use numerical and graphical methods, identify the shape of data distribution for the quantitative variables, and compare the dispersion of quantitative variables based on qualitative variables. It may be confusing, but that is the point of this study case. Therefore, the overall aim of this study would be to determine the relationship between age and systolic blood pressure, as I've mentioned of the title before. It intended to identify whether any variations in age, body temperature would have an immediate impact on the predicted systolic blood pressure. The research included a number of methodologies, including graphical and numerical tools, and the SPSS was applied to evaluate the data. To sum up, all the techniques employed make our project simpler and save us tremendous amount of time. In order for us or anybody else in the future to comprehend the data provided, all methods are dependable. So that is all from us.
Assalamualaikum to Ms. Juliza. Our group 5, will present about a study on variables weight and waist circumference, the descriptive, correlation, and regression analysis. There are 4 members in my group, which is Arifah Ilyana binti Muhammad Fazel, Farah Yasmina binti Sabri, Norazeera Shaheera binti Ramli, and me, Sharifah Mirza Yohanis binti Wa'ibra.
Body mass index values of more than 25 and more than 30 are shared by about 15% and 50%, both of all British adults respectively. Greater emphasis on prevention is required, especially among young people who frequently have minimal contact with healthcare due to the ineffective management of obesity and rising related health expenses. While most members of the public are able to compute their body mass index to determine their personal risk or need for weight control, many health professionals are already aware of the safe range for BMI, which is in 20 and 25. High blood pressure, plasma lipids, and insulin resistance are the 3 main metabolic cardiovascular risk factors that independently accumulate with body mass index and the waist to hip ratio, and to become better with weight loss. Waist circumference is the best indication of changes in intra-abdominal fat following weight reduction and has a close relationship to body mass index. It is also the main parameter in the waist to hip ratio, which indicates the percentage of body fat that is intra-abdominally rather than subcutaneously. The main condition acting as a base for the development of metabolic syndrome is abdominal obesity. The most straightforward, useful, and popular technique of categorizing body weight is the BMI. It is determined by dividing body weight in kilograms by the square of body height in meters. The index classifies patients into the proper weight categories of underweight, normal weight, overweight, and obese. Even while BMI is frequently used to track the prevalence of obesity in the community, it has many drawbacks. It offers no detail on how the adipose tissue is distributed inside the organism. The BMI is a computed statistically measure that does not account for physiological variations in the proportions of adipose, osseous, and muscular tissues. In addition, its worth varies according to factors, including sex, age, constitution, and training. Based on the results of the research that have been done, it is clear that abdominal obesity, which is measured by the circumference of the waist, is crucial for the emergence of metabolic diseases and for determining the risk of cardiovascular disease. Abdominal obesity is defined as the waist circumference of 80 cm or more for women and 94 cm or more for males, as per the 2005 IDF guidelines that were later amended in 2009. It causes insulin resistance, which lowers HDL cholesterol levels, raises triglyceride levels, and causes arterial hypertension. Insulin resistance is the cause of this. All of the conditions mentioned are linked to the development of metabolic syndrome, type 2 diabetes, and ischemic heart disease. In the development of metabolic changes that result in type 2 diabetes and cardiovascular disease, regional body fat distribution is more vital than total body fat. Abdominal obesity has been linked to both an elevated risk of cardiovascular disease and the symptoms of insulin resistance syndrome. Assessment of abdominal visceral adipose tissue (AT) build-up is crucial, and it may be done using imaging methods including magnetic resonance imaging and computed tomography (CT). These methods have been beneficial for examining the geographical distribution of body fat. However, they are pricey, cannot be used for field research, and in the case of CT, the radiation exposure restricts their usage. Some studies have created straightforward anthropometric measures to predict visceral AT accumulation in order to get around the limitation of using imaging techniques. The most popular predictors are waist girth and waist-to-hip ratio, which are WHR. Both cross-sectional and longitudinal investigation have demonstrated that visceral AT accumulation and waist circumference are more significantly correlated than WHR.
Objectives of the study are as follows. First, to describe the quantitative variables of weight and waist circumference and qualitative variables of gender using graphical and numerical techniques. Second, to determine the shape of data distribution for weight and waist circumference. Third, to compare the dispersion of weight and waist circumference based on gender. Fourth, to determine the correlation between weight and waist circumference. Fifth, to predict waist circumference based on weight. Sixth, to determine the accuracy of prediction of waist circumference based on weight.
I am Farah Yasmina, and I'm gonna talk about significance of study. Based on our study, we can get a new knowledge from general terms to specific. We can also discover on how to classify the type of variables which are qualitative and quantitative. Based on our study, the qualitative is gender, and for quantitative is weight and waist circumference. We can also identify independent and dependent variables. For our study, for the independent variables is weight, and for the dependent variables are waist circumference. We can also develop graphical tables such as histogram and box plot, and we can also learn on how to read the SPSS output.
Data description. Brief descriptive coefficients known as descriptive statistics are used to sum up a set of data that may represent the full population or only a sample of it. Measures of central tendency and measures of variability comprise descriptive statistics. The mean, median, and mode are measurements of central tendency, while the standard deviation, variance, minimum and maximum variables, and skewness are measures of variability. In order to do statistical analysis, secondary data is used in this research. The weight and waist circumference of 82 people were included in this data collection. The information for this study was obtained from this link. Table 2.1 below shows the description of the data for this project.
In this study, the distribution of data for each the variable present is determined by using a graphical technique. The type of graph that is used for each variable is shown in this table. For qualitative, the variable gender, the graph used is vertical bar chart. For type of variable quantitative, the first variable is weight. The graph used is box and whisker plot and histogram. For the variable waist circumference, the graph is box and whisker plot and histogram. And for the variable waist circumference and weight, the graph is scatter plot.
In addition to graphical techniques, numerical techniques are also being applied in this study to observe each characteristic of the quantitative variables. Table 2.3 here displays the methods that were used in numerical techniques. In that table, we can see that the statistics for the measure of central tendency are mean, median, and mode. For the measure of dispersion are variance and standard deviation. Measure of position are first, second, and third quartile. And lastly, for the shape of data distribution, the statistics is Pearson coefficient of skewness. The data for qualitative variables are not suitable for interpretation using the numerical techniques listed here. The frequency distribution table needs to be used to better explain the qualitative variable. A variety of numerical measures are used to summarize data. The most often used numerical measurements for quantitative data are the mean, median, mode, percentiles, range, variance, and standard deviation. When calculating the median, the data values are first ordered from least to greatest. The median is the middle value when there are an odd number of data values. The median is the average of two middle values when there are an even number of data values. The mode or most frequent data values is the third way to quantify central tendency. Percentiles show how the data values are distributed throughout the range from the lowest value to the highest value. The first quartile refers to the 25th percentile, the second to the 50th percentile, also the median, and the third to the 75th percentile. Quartiles split the data values into four sections. The easiest way to measure data variability is range, which is the difference between the highest and smallest number. Only the two extreme data values are used to determine the range. On the other hand, the most often used measures of variability are the variance and the standard deviation, which are based on all the data.
The table shows the method used in order to achieve the objective of this study. So, for the first objective, to describe the quantitative and qualitative variable using graphical and numerical techniques, the method used is histogram and box plot. The second objective, to determine the shape of data distribution for qualitative variable, the method used is measure of skewness. The third objective, to compare the distribution of weight and waist circumference based on gender, the method used is coefficient of variation. The fourth objective, to determine the correlation between weight and waist circumference, the method used is Pearson coefficient of correlation. The fifth objective, to predict the amount of weight and waist circumference, the method used is regression coefficient. And lastly, to determine the accuracy of prediction of waist circumference based on weight, the method used is coefficient of determination.
Next is data presentation. Figure 3.1 and Table 3.1 shows bar chart of gender and frequency distribution of gender of 82%. Both male and female are having the same percentage, which are 50%. Figure 3.2 is a histogram for weight, and figure 3.3 is a histogram for waist circumference. Both of these histograms shows that the data distribution are skewed to the right. Next is figure 3.4 is a box plot for weight, and figure 3.5 is a box plot for waist circumference. Both of these box plots shows that data distribution are also skewed to the right. Next is measure of skewness. Skewness is a measure of asymmetries or distortions in symmetric distributions. A distribution might have left or right skewed distribution. Gleason coefficients of skewness are used to calculate. Based on this table, it shows that both weight and waist circumference are skewed to the right. This indicates that both weight and waist circumference are both positively skewed.
This research studied both qualitative and quantitative factors, as was described in section 2.1. The combination of measures of central tendency, including mean, median, and mode, as well as measures of dispersion, like variance and standard deviation, and the location of the first, second, and third quartile, allows for additional analysis to be done with quantitative variables. In addition, the coefficient of variation can be used to determine which group of people has most stable in weight and waist circumference. Table 3.3 shows that the lowest weight is 39 kg, while the highest weight is 152 kg. For waist circumference, the lowest value is 62 cm, while the highest value is 135 cm. Measure of central tendency is a summary measure that attempts to describe a whole set of data with a single value that represents the middle or center of its distribution. Mean, median, and mode are common measures used to describe central tendency. Table 3.4 shows the summary of measure of central tendency for this research. The table indicates that the average weight is 72.24 kg, half of person weigh more than 67.75 kg, and another half weight less than 67.75 kg. Most of person weigh 61 kg. While for waist circumference, the average waist circumference is 87 cm, half of person waist circumference more than 83.25 cm, and another half waist circumference less than 83.25 cm. Most of person waist circumference is 72 cm. Measure of dispersion indicates the scattering of data. It explains the disparity of data from one another, delivering a precise view of their distribution. The measure of dispersion displays and gives us an idea about the variation and the central value of an individual item. These measures are called the standard deviation of the set, the variance of the set, and the range of the set. The more spread out or dispersed the data are, the larger will be the variance and the standard deviation. The more clustered the data are, the smaller will be the variance and the standard deviation. If all data values are the same, there is no variation in the data. The variance and standard deviation will be equal to 0. Variance and standard deviation can never be negative. Measure of position determines the position of a single value in relation to other values in a sample or a population data set. Quartiles are the values that divide a list of numerical data into 3 quarters. Table 3.6 shows that 75% of persons weigh more than 60.9 kg and 25% of persons weigh less than 60.9 kg. 50% of persons weigh more than 67.65 kg and 50% weigh less than 67.65 kg. And 75% of persons weigh less than 78.28 kg and 25% of persons weigh more than 78.28 kg. While for the waist circumference, 75% of persons waist circumference more than 76.23 cm and 25% of person waist circumference less than 76.23 cm. 50% of person with circumference more than 83.25 centimeter, and 50% with circumference less than 83.25 centimeter. Last but not least, 75% of person with circumference less than 95.23 centimeter, and 25% of person with circumference more than 95.23 centimeter.
Next is coefficient of variation. Coefficient of variation is also known as relative standard deviation. The standard variation to the mean ratio illustrates the degree of variability in comparison to the population mean. The higher the dispersion, the higher the coefficient of variation. After we calculate the coefficient of variation, it shows that the coefficient of variation for male weight is lower than female weight. This indicates that the coefficients of variations for male weight are more consistent than female weight. Next is coefficients of variations of waist circumference. It also shows that male is lower than female. This also shows that the coefficients of variations of waist circumference for male are more consistent than female.
Correlation and regression analysis. This here shown the scatter plot of weight and waist circumference of a person. Scatter plot can assist highlight the strength of a linear relationship between two variables in correlation. Scatter plots frequently include a fitted line for regression. Scatter plots are frequently used in qualified control to display specification limits or reference lines. The scatter plots indicates that there is a moderate positive correlation between weight and waist circumference here. Based on this table of model summary and coefficients, the Pearson correlation is 0.885, which means that there is a strong positive correlation between weight and waist circumference of person. This also can be seen from the scatter plot. The y-intercept is 38.323, indicating that when the weight is 0 kg, the waist circumference is 38.323. The slope is 0.674, meaning that when the weight is increased by 1 kg, the waist circumference also increases by 0.674 cm. The complete regression equation is y equal to 38.323 plus 0.674x. The coefficient of determination is 0.783, which is under this R square in model summary table, which are equal to 78.3%. The 78.3% of total variation in waist circumference of a person can be explained by weight using regression equation. The prediction of waist circumference if the weight is 82 kg. So the 82 kg we substituted into x inside the complete regression equation, which is as shown here. Y equal to 38.323 plus 0.674, open bracket 82 close bracket, which is equal to 93.591 cm. That is the waist circumference.
This is the study of the relationship between weight and waist circumference. The goal of this research is to predict waist circumference based on weight and to determine the accuracy of the prediction. To describe the quantitative variable of weight and waist circumference and qualitative variables of gender by using graphical and numerical techniques. To determine the shape of data dispersion, the correlation between weight and waist circumference, and to compare the dispersion weight and waist circumference based on gender. The Completion of this study yield a variety of advantages, including the equations of statistical skills using SPSS. We learn how to read SPSS data and construct the data to obtain the Pearson coefficient of correlation, coefficient of determination, and regression coefficient. As a result, this study has a significant impact. To conclude, all the methods that have been used make our project easier and save a lot of our time. All the methods are available for us or anyone to interpret data. The regression is very important as a part of the data, as it's showing the strong relationship between two variables, in which by the arrangement of the plot. The SPSS data allows us to state the information derived from the data given and to determine the standard deviation, the dependent and independent variables. To be specific, the results such as graph of the data such as vertical bar chart, histogram, box and whisker plot, and scatter plot, and even the regression is very important so that it's easy for the data collector to classify the subject and the problem segment of the situation that made the data either to be balanced or it is imbalanced. These are the references for our group research.
Good morning, Ms. Julisa. We are from Group 6. We will present our project STA108 case study, which the title for our case study is a study on variables amount of calories and total fat in fast food, the descriptive, correlation, and regression analysis. Before starting this presentation, I will first introduce the members of this group. First of all is myself. My name is Anak. My student ID is 2020-82C434. Next is Karen Kasim Frederick, 2020-832768. Caroline Jerida Anak Tambay, 2020-244X72. Next is Senorita Anak Billy, 2020-479-472. And lastly is Amelda Amelia Angel Anak Temenggong, 2020-497264.
Let's start with the introductions. The variables of this case study are calories and total fat in fast food. A calories is a type of energy unit. Calories are the energy people get from the food and drink they consume, as well as the energy they use in physical activities, whereas total fat is the number that indicates how much fat is in a single serving of food. People would probably live healthy life if they only consume the number of calories required each day. Calories intake that is either too low or too high will eventually cause health problems. Furthermore, not everyone requires the same number of calories per day. People's metabolism burn energy at different rates, and some people lead more active life than others. Overall, people who eat fast food consume more calories as well as more fat and refined sugar. For example, because young adults eat a lot of fast food, we expect a strong positive correlation between total fat content and calories intake. Moreover, it is important for us to count the calorie of food and drinks that we consume in order to consume the number of calories required each day. There are two ways in calculating food calories. First is by calculating calories by nutrients. Second method is by using calorie calculator or guidebook. Finally, we may acknowledge the links stated in slide for providing the data source for this case study. Moving on to objectives. The first objective of this case study is to describe the quantitative and qualitative variables using graphical and numerical technique. Secondly is to determine the shapes of data distributions for qualitative variables. Next is to compare the dispersions of total fat content in the food and the amount of calories in food based on both discrete and continuous qualitative variables. Besides is to determine correlations between the total fat content in food and amount of calories in food. Finally is to predict the amount of total fat content in the food and amount of calories in the food.
Next presentations are present about the significance of this study. The outcome of this study has a variety of advantages, including the improvement of statistical knowledge using SPSS. In addition, by applying the concept that has been learned during lectures to these projects, lead to a better understanding. For instance, through this study, it's constructing a statistical report. In addition, we are able to interpret SPSS data, present the information from the data by providing an explanations, and create regression equations and even draw conclusions from the SPSS data. Other than that, the bond among we researchers also become closer after finishing this project together, whilst helping each other to be more understand statistical knowledge. Moreover, this statistical research is essential for our future professions, since we are pursuing an applied science course. Through this research, students are also able to know the correlation between the amount of calories and total fat in the food. For community, this may help to balance out their diverse view and reaffirm information that has been learned from the research on the same study. This is because these studies are documented and presented statistically for a better comprehension. Next presentation is our data descriptions. Firstly, the study is conducted by using secondary data, meaning it was obtained from online resources. It consists of two quantitative variables and one qualitative variable. Of all of the data included in the qualitative variables are breaded chicken sandwich, burger, chicken nugget, french fries, and grilled chickens. The description of data obtained is described in the table provided in the slide. As we can see here, the amount of calorie in the food and the total fat content in the food is both continuous quantitative and is also existed in the level measurements of interval. The last one is the type of the fast food, which is in the qualitative variable, and the level of measurement is nominal.
Graphical techniques are a visual way of presenting data in the form of charts and graphs. The type of graph that are used for each variable on our case study are shown in table 2.2. For the quantitative data, which are the data of number of calories and data of the total fat content in the fast food, I use the histogram and box plot to present the data in graphical method. Next, for the qualitative data, which are the data of type of fast food, the bar chart is picked to express and analyze the data.
So for numerical technique, the purpose of describing data for qualitative variables, the numerical methods presented in table 2.3 above are inapplicable. So to further clarify the qualitative variable, we may still utilize a frequency distribution table. The quantitative variable that was selected as independent and dependent variables, the total fat content in the food and the amount of calories in the food are shown in table 2.2 respectively. So more research was done into the potential link between an estimate of the total fat and the amount of calories in food using a scatter plot and the Pearson coefficient of correlation. The best fitting regression coefficient is also found via regression analysis. Numerous numerical measurements are being used, as may be seen in table 2.3. Measures of central tendency in a numerical value distribution include the mean, median, and mode. So the variability in sample or population is described by a measure of spread, also known as dispersion. So this provides a general overview of a set of data. So in order to derive variance and standard deviation, it is typically employed in conjunction with a measure of central tendencies, such as the mean or median. A rank ordered data collection is divided into 4 equal pieces by quartiles of values that divide each sector, and they are denoted by the letters Q1, Q2, and Q3 respectively. So the coefficient of skewness is the final factor that determines the form of the data distribution. It gauges the asymmetry of distribution. So the tail is thought to be longer to the right when the skew is positive and to the left when the skew is negative. So a distribution that is entirely symmetric, like the normal distribution, has 0 skews.
Moving on, I'm going to share the method used to achieve objectives. Firstly, the method used to describe the quantitative and qualitative variables using graphical and numerical technique are by using box plot, histogram, bar chart, measure of central tendency, measure of central locations, and measure of dispersions. Next, the method used to determine the shapes of data distributions for qualitative variables is Pearson coefficient of skewness. Besides, the method used to compare the dispersions of the total fat content in the food and the amount of calories in the food based on both discrete and continuous qualitative variables is coefficients of variations. In addition, the method used to describe correlations between total fat content in the food and the amount of calories in the food is Pearson's coefficients of correlations. Lastly, the method used to predict the amount of total fat content in the food and the amount of calories in the food is regression analysis.
First, based on data and result that we can see at the figure 3.1, bar chart of the type of fast food and the table 3.1 which shown the frequency distribution of the type of fast food, there are quite big difference in frequency and percentage between burgers and other type of fast food. The frequency and the percentage of the burger are the highest, which are 69 and 54.8% respectively.
Next, I'm going to share the figure that represent the histogram and box plot for variables of the amount of calories and the total fat content in the food. Firstly, we are able to see that the shapes of data distributions of figure 3.2 and figure 3.3 of histogram and box plot for the amount of calories in food are both skewed to the right. Moving on, we can see that the shapes of data distributions for both figure 3.4 and figure 3.5 of histogram and box plot of total fat content in the food. We also see that the shapes of data distributions for both histogram and box plot for the total fat content in food are skewed to the right. In addition, the outlier of box plot of the amount of calories in food and the total fat content in the food is both 14.
Move on to the section measure of skewness. From the Pearson coefficient of skewness that shown in table 3.2 above, both of variable amount of calories in the food and the variable total content in the food are skewed to the right, which is positively skewed. where the skewness is 0.650 and 1.059 respectively. As both of the variables are skewed to the right, it indicates that the amount of calories and the total fat in fast food are less than average. Besides, we can see that both values of skewness are far away from zero, which confirm the shape of data distribution as depicted from graph that we presented in section 3.1.
So for descriptive statistic analysis, so according to table 3.3, fast food has a minimum calorie count of 130 kilocalorie and a maximum calorie count of 1,240 kilocalorie. So the minimum and maximum amounts of total fat in fast food are 4 grams and 87 grams respectively.
Alright, next presentation is about our measure of central tendency. Firstly, I would like to mention about its definitions. It is a descriptive summary provided by a single value representing the center of the data distributions. One of the most common measure of central tendency is mode, which is the most frequent value. Next central tendency is median. That is the middle number of ordered data sets. Lastly, mean also one of the most common central tendencies that been used, which is it is the sum of all value divided by the total number of values. Okay, I would like to continue my central tendency presentations. As shown in the summary statistic for measure of central tendency table at the paste in the slide, it indicates the average amount of calories in the food is 532.49 kilocalories, while the average total fat in the food is 28.54 grams only. It also recorded that the half of the amount of calories in the food is more than 515 kilocalories, and another half of the amount calories in the food is less than 515 kilocalories. For total fat in the food, half of it is more than 28.54 grams, and the other half of the total fat in the food is less than 28.49 grams. Lastly, most of the amount of the calories in the food is 380 kilocalories, while most of the fat in the food is only 11 grams. That's all from me. Thank you.
Next, let's discuss about the concepts of measure of dispersions. A measure of dispersion indicates the scattering of data. It explains the difference in data, providing a precise pictures of distributions. Furthermore, this table shows that the standard deviations for the amount of calories in food is 250.844, whereas for the total fat contained in the food is 18.241. We can see that the standard deviations of amount of calories in the food is higher compared to the total fat contained in the food. Next, the variance for the amount of calories in food is 62,922.860, while for the total fat contained in the food is 332.733. This shows that the variance of the amount of calories in food is higher than the total fat contained in the food. Besides, the range of the amount of calories in the food is 1,110, whereas for the total fat contained in the food is 84. This shows that the range of the amount of calories in the food is higher compared to the total fat contained in the food.
For the central location, in the table above, it shows that 25% of the type of fast food have less than 330 amount of calories, and 50% of the type of fast food have an amount of calories less than 515, while 75% of the type of fast food have an amount of calories less than 675. And then for the next one is 25% of the type of fast food have less than 14 total of fat on the food, and 50% of the type of fast food have total of fat less than 22.50. And 75% of the type of fast food have total on fat less than 14. So for the coefficient of variation, in the slide there is a table, and it shows that the coefficient variation for calories and the total fat. So for variable calories, the mean for type of fast food for the chicken nugget hits the lowest mean compared to the other type of food, which is 274.55, and meanwhile, burger had the highest mean for type of fast food, which is 620.20. And the mean for breaded chicken sandwich is 522.09, while for French fries is 314.08. And the grilled chicken sandwich had 408, and milkshake had 606 and 67.67. So the for coefficient of variation shows that the French fries, which is 50.821%, is the lowest calories, which make it more consistent compared to the other types of fast food. For the total fat in the food, burgers have the highest mean total fat content, which is at the 35.91, while French fries have the lowest, which is 15.31. So the mean values for the milkshake, chicken nuggets, grilled chicken sandwich, and breaded chicken sandwich are 26.02, 22.58, 17.37, and 17. So the burgers rank the best for standard deviation with values of 20.351. For French fries rank lowest with a value of 2.779, and the chicken nugget is 10.951, and for milkshake is 10.388, grilled chicken sandwich is 9.657, and the breaded chicken sandwich is 9.2
18.02. And then for French fries, which has 18.151%, and the chicken nuggets has 63.3055%, had the highest and lowest coefficients of variations. So, respectively, grilled chicken sandwich have a coefficient of variation 56.806%. Burgers have a coefficient of variation of 56.672%. Milkshake have a coefficient of variation of 46.005%, and a breaded chicken sandwich have a coefficient of variation of 35.672%. For the correlation and regression, the most commonly used techniques for studying relationship between the variables, and the correlation used to show the relationship between variables, and linear regression by use equation to express the meaning. So the regression also refers to linear regression. Based on this graph, it shows that a strong positive correlation between the total fat and the calories. This is the SPSS output, which we can interpret a lot of things from the table. Based on the SPSS output, the Persian correlation is 0.941, which means that there is a strong positive correlation between total fat content in the food and amount of calories in the food. So the coefficient of determination shows in the table is 0.885, which is that shows 88.5% of total variation in the amount of calories in the food can be explained by the total fat that content in the food. Meanwhile, the 11.5% can be explained by the other factors. So for the slope, which is B, in this table is 12.937, which indicates that for every 1 grams increase in total of fat content in the food, the amount of calories in the food will increase by 12.937. And for y-intercept, 163.211 means that when total fat content in the food is 0 grams, the amount of calories in the food is 163.211 kcal. And the complete regression equation is y equal to 163.211 and 12 plus 12.967x. So after we substitute it into the equation, we get that the answer is 568.384 kcal. So we can predict that when the total fat is 29 grams, the total calories in the food is 568.384 kcal.
In conclusion, from Chapter 1 to Chapter 3, we could collect and analyze data using various methods. All the methods are reliable in order for us or anyone to interpret and analyze data, especially by using SPSS, where it's useful for data analysts to use diverse data sets and perform various statistical analysis, such as regression analysis, for analyzing diverse data sets and determining the relationship between the dependent and independent variables. Overall, from our case study, it shows and proves that the total fat in fast food will affect the amount of calories in the fast food. That's all the presentation from our group. Thank you and have a nice day.